Okay, ladies and gentlemen, would you please focus? We are going to be talking about function notation. We did some function notation last semester, and some people were confused about what it means, so we're going to go over that right now. So if we're using function notation, we're probably looking at functions. Have you heard the word functions? Yeah. Probably since, certainly since Algebra 1 and maybe even earlier than that. So that means you do know what a function is, of course. Or maybe you've forgotten. And so right here on your paper it says a function is a set of ordered pairs in which each component is matched up with exactly one second component. Is that hard to understand? That did not seem clear to me. I can remember being in Algebra 2 class very, very, very long time ago and not understanding that definition. It's really pretty simple. There's no repeated x values. A function has no repeated x values. And this is a function. This is read f of x. The first thing you need to know is this does not mean variable f times variable x. That's what this does not mean. F is not a variable. F is the name of the function. X is the variable. It stands for the input. Did you use the words input and output in Algebra 1 possibly? Well, what is the input? The number you put in. Would that make sense? And the answer is the output. And this particular function rule says I'm going to multiply by 2 and then add 12 and then divide by whatever the x is. So the main thing you need to understand is this does not mean that f is a variable. F is the function name and the variable is x. Could the variable be a different number instead of x? Often in physics, you will have function notation with maybe f of t or h of t. It will be a variable t. In physics, what might the t stand for? Often it stands for time. So the function name can change, the variable can change, but this is what function notation looks like. And we're just going to touch the edges of function notation. Function notation really becomes very, very useful when you get up to a class called calculus. So here we have 3 functions. This first function is named f, and this function is named g, and this function is named h. So open up your paper so you can see these. And so what does this mean? You say this, f of -6. So, since it starts with f, I am going to use this function. What am I going to do with the -6? Plug it in where? In place of the x values, I am going to put -6. Now this negative sign is from the function rule. And this negative sign is from the -6. Minus a minus makes a. Now, if you had a calculator, and if you put it in the calculator like that, you would get the wrong answer. Because that's the wrong way to put it in a calculator. If you had a calculator, you would need to put a parentheses around that -6. Since we don't have a calculator, we just have to square -6 squared by ourselves. So what's -6 times another -6? And so when we add that together, the answer is 42. The output is 42. Now, this is a quadratic function. Do you know why I would call that a quadratic function? Oh, you've forgotten everything you knew about quadratics? Because the x is squared. So if I graphed it, it would be a parabola. And the input was -6, and the output was 42. -6, 42 would be one of the points on the parabola. That's what you're calculating when you are calculating a function rule. So this starts with h, so I'm going to use this function over here. So please evaluate h of 3 on your paper. So when you plug in a 3 into the function h, you would get -6 minus 4, and so the answer would be -10. Example number 4. Evaluate. Did I? Wonder what happened. Okay, we'll just skip to 4. So on problem number 4, would you please evaluate g of 5? Did you get 21? I would hope that this is fairly easy. If you're going to substitute in a -2, you're going to plug in a -2. You're going to have -2 times a -2 minus 4. What's -2 times another -2? What's 4 minus 4? Does that mean no solution? A lot of times people, whenever they had a 0, they were writing down, well, no solution. The solution is 0. This is a linear equation. Do you know what the slope is of that linear equation? It is a straight line. Do you know what the slope of that straight line would be? -2 is the slope of this line right here. Do you recognize it as being in y equals mx plus b form? And the slope would be -2. And what would the y-intercept be? -4. And so what this means is my input was -2. My output was 0. One of the points on this line right here is -2, 0. That's what you're finding when you're finding the function rule. One of the points on the graph. Except, skip to number 9. What does this mean? Am I going to substitute in a number this time for my input? Well, not just a number. I'm going to substitute in an expression. So in the function f of x, in place of the x, I'm going to substitute in n plus 2. So what am I going to do in place of that x? N plus 2. What am I going to do in place of this x? When you square that, is that going to be n squared plus 4? Do you square the first one and square the last one? Well, algebra 2 forever if you do that. This means n plus 2 times another n plus 2. So I'm going to go over in the side of my paper, the margin of my paper, and I'm going to multiply out with a box problem. Do you remember box problems? You can use FOIL, but as you know, I prefer a box problem. And so when you multiply that out, you get n squared plus 4n plus 4, because you're going to combine like terms right there. Is this going to be minus n plus 2? That's too many. That's a major math mistake. Can you find my major math mistake? Which sign? You have to distribute the negative, and so that when you subtract that, that would be minus n minus 2. And then you need to combine like terms. And since I substituted in an expression, I'm going to have some n's in my answer. I'm not going to be able to get to a single number answer because this right here was not a single number that I substituted in. So you try this one, please. How did you do? You plug in the n minus 4 in place of the x, and then you distribute, and then you combine like terms. Why didn't I have to use a box problem in this one? Did I have an expression? Did this have anything squared? So I didn't have to use a box problem for that one. So what am I going to use for my input in this problem? So I'm using this function, and in place of this x, I'm inputting a 3x. So this is going to be 9x plus 6. There's no like terms to combine. On problem number 13, what does that mean? F plus g of x. That's how you say it, f plus g of x. It means you do what to both equations? Add them. And so this means that you write down this equation with the variable x and add it to this function rule. You add those two function rules together. And so if you add those two function rules together, you need to combine those like terms. So that just means add the function rules together and combine like terms. We actually had some problems like that on the review and also on the final exam in the fall. What is problem 14 asking me to do? Write down the function f and subtract the function g. Why did I have to put a parenthesis around it? Am I subtracting the 3x or the 6 or all of it? All of it. So you have to distribute the negative and combine like terms. What like terms? Which terms are like terms? That's the ones. And so this would be 4x minus 6. X squared minus 4x minus 6. So what is this asking me to do? Write down the function h, write down the function g, and subtract them. G is minus 3x plus 6. Once again, you are going to distribute the negative. Distribute the negative. Distribute the negative. These are like terms. These are like terms. Combine the like terms. Because this says what? So I'm going to subtract this term and that term because both of those are part of G. Did that answer your question? What does this mean? No, it doesn't mean times 4. It means add them together and then input the 4. Not multiply it by 4. Add these two together and input the number 4. You could also input the number 4 first and then add them together. You will get the same answer, but we're going to... Matter of fact, we already added those together in a previous problem. Didn't we already add those together? What did we get when we added those together? No, when we add them, we get 2x plus 6. And now this tells us in place of x, what are we going to put in place of x? And so that would be 4 squared plus 2 times 4 plus 6. And so we're going to add those all together for a total of 30. This doesn't have any x's in the answer because we have put in the number 4 in place of the x's. What does this mean? Subtract these two functions and then input the number 3. F minus g of x, we already did that in a previous problem. If we subtract this from that, we get x squared minus 4x minus 6. We did that in a previous problem. But this problem says after you subtract it, then input the number 3 in place of the x. So in place of the x, I'm going to put in the number 3. So this is going to be equal to 3 squared is going to be 9 minus 12 minus 6. And so that would be equal to a negative 9. On your homework paper, we have function named h, and the variable is a instead of x. And it asks me to find h of negative 2. H is the name of the variable. Excuse me, that's not right. H is the name of the function, and the variable is a. And this means in place of the a, substitute in a negative 2 in place of the a. Now, what does this mean? No, it is an absolute value. We are not going to do case 1 and case 2 because are we solving for x? You do the case 1 and case 2 when you're solving for a variable. We're not solving for A because we know that A is equal to -2. We are evaluating, not solving, and so we don't have to do the case 1 and the case 2. Well, what do we do then? Well, if you add those together, that's going to give you absolute value of -5 plus the number 1. Way back in September, we learned that the absolute value does absolutely nothing to positive numbers, but negative numbers are changed to positive numbers because the definition of an absolute value is how far away from 0 are you. So if you're over here at -5 on the number line, you are 5 units away from 0. All the absolute value does is change a negative number to a positive number so that the answer is 6. Do you understand why we don't have to do the case 1 and the case 2? We are not solving for X. Just one second here. And so on your assignment, this assignment will be due on Friday, and no late papers are accepted.